Hello guys, hope you are doing good. In this video, we are going to discuss about the end-to-end wiring of a circuit having a PLC in it. So let's begin. Now, I'll just identify a few important parts here. This one is an MCCB, molded case circuit breaker. Here it's a contactor, three-phase contactor as you can see, phase 1, 2, 3. This is an auxiliary contact. Here, this is an OCR, overcurrent relay, for the protection of overcurrent in the motor. And then we have a induction motor, which could be coupled to any load. For example, it could be coupled to a pump or a fan or anything else, any other machine.
To every marine engineer out there, from junior engineer to chief engineer and electrical officer, we all know that earning respectship is very important. We all know fast promotions are very important, and we all know that इज्जत कमानी है, promotion चाहिए तो काम आना चाहिए, तो जूते पड़ते हैं, गालियां पड़ती हैं, and for that you need a good mentor. Sometimes we keep finding those mentors on board ship, अगर नहीं मिल रहे तो MNDFLIX है ना, Merchant Navy Decoded has launched a subscription model where you can find more than 30 plus courses with respect to your rank, helping you earn respect on ship. Please enroll on these free trial videos, watch these videos as per rank, and then decide whether you want to invest or not, with a very good flexible payment plan as well. Jai Hind, Jai Bharat, Jai Mother.
What else? We have a control transformer. So it is going to step down 440 into a lower voltage, right? Whatever we need. Here, this is an AC to DC converter. Input is AC. This range, 110 or 220, whatever you want to put it here. And the output is 24 volt DC. Plus comes out of here, minus comes out of here. Okay. Then we have switches, a plus, a start switch, a stop switch. Then we have some indicator lights, red indicator light, green indicator light. A relay optionally have been put, and this float switch optionally we have put this one optionally. Then finally we come to a PLC. So in the PLC we have got some inputs channels, some output channels, the indicator lights for these channels, the indicator light for the health check of the PLC, some communication port, and even some switch button to run the PLC or not. Okay, so this is mainly the items are. Now we can begin with the wiring. So first of all, understand that this section here is the power section, power circuit. Basically 440 volts will flow here, including this one. Okay, for now I'm not using this contactor, I'm just keeping it separate. So you can see now here, this is the power circuit, which will be having 440 volts. Rest of it is on the lower voltage section. So let's first wire the 440 volts power circuit. And even if you have, or if you do not have PLC, it does not matter. Power circuit will still be there, right? That's a main circuit, one of the main circuit. And irrespective of whether it is controlled by PLC, microcontroller, relays, anything, power circuit will still be there and almost identical to any kind of control system. All right, so let's power this up. So firstly, we will need power input, three phase. Let's suppose the power input is coming from the top. Okay, it's coming from somewhere. I don't know where that is, but it's coming from somewhere. Perhaps the main switchboard. Okay, and then it goes, we will be connecting this to this contactor. So these wirings will be done normally. So I'm just connecting the red phase wire, firstly the red phase wire, and from the OCR output is coming from here, T1, and it goes in the motor like this. All right, so once again, MCCB input are then goes to the L1, comes out of the T1 and goes into this OCR, comes out of T1 and then goes to the motor, right? So we have wired one phase. Let's wire another phase, RYB. So the yellow one now here. So output from MCCB will go to this L2 and comes out of T2, goes here, comes out of T2 here, goes here. Fine. Then we'll wire the blue cable. There we go. Okay, so we will wire the three different cables like this, and they will enter through this terminal box, right? These through this here through them, but I've shown it like this anyway. So this is the main power circuit wiring done. Okay, so how does this work? When you switch it on, power is available at the input of the contactor, which is a three-phase switch, which is controlled by a coil inside. Okay, there is a coil. Where is the coil current coming into? The coil current comes into A1, A2. Where is that? Well, in this picture you can see there is two more terminals inside A1, A2, which is working on a lower voltage, let's say 220 volt. You can see 220 volt. These three are 440 volts. This is a single phase 220 volt to power the coil inside. So how does the coil look like? Let's say I just draw a coil. So inside there will be a coil like this. What is the job of the coil? Well, when the coil is energized, this becomes electromagnet and it will close this switch. So the red joins to output red and yellow to output yellow. So basically this switch is on when the coil is energized. So the coil has to be energized from the control circuit. All right. Okay. So all right then. So this is the power circuit. Only one thing remaining is we also need to give the power to the control transformer from the same 440 line. So first of all, let me write the input as, let's say the specification given in this transformer is this one, 220 volt. Output is 220, input is 440. Let's say this is the input. Assuming this is the input. So I need to connect any two phases to this input. So how that goes? Like this one and this one like this. Okay. So since I cannot take it from this wire, so I will just take it from this joint. All right. Okay. Let's take this cable or this cable here and join that to the input somewhere. Okay. So let's join that to the input. So there we go. Goes to the input. The next cable will be either yellow or blue. Totally depends on me. Where do I want to connect it? And there we go. Okay. So what I've done is I've connected the 440 into the input section. So this wiring is done. Now what about the output? Output is 220. Right? And where do we need this output? Well, if anywhere there's a single phase AC supply needed, I will give it from here. Suppose this one, AC to DC converter, which is nothing but rectifier. This is needing input as AC. Okay, so I can give it to this. This is live, neutral, doesn't matter. In AC, polarity doesn't matter. So what I can do here is, for me, let's say this is the here we go. I've connected one phase here, and let's say another phase will be what color? Let's say I need a different color. Okay, and there we go. Depends on where it is connected to. Yeah. So you can read the labeling where which port says 220, you can connect there. So there we go. So we have connected the 440 line and we also connected the control transformer, as you can see. So now we have power in the input of this AC DC converter, which is nothing but rectifier, and we need a DC 24 volt output. So here is the positive terminal, here is the negative terminal. So let's the positive terminal be connected with the red. So this time I'm just taking the red out. Okay. So from the positive here, let me connect it like this. And from the negative, so first from the positive and then from the negative. Okay. So yes, we have this bus positive negative terminals. Yeah. Let me just take it and completely take it to the extreme. Oops. Doesn't look good this way. Anyway, doesn't matter. Okay, and here I'm the red one. All right, so this is complete now. The red one is 24 volt and the black one is 0 volt. Okay, so red is positive, black is negative. Now, so we have given powers to almost everything that was needing the power. But yes, my PLC also needs power. And you can check the manual what power is needed. If it is says 24 volt DC supply, so then we can, wherever the power port is there, we can just supply the power. Let's say that power port is somewhere this side. Oh, my bad. So power port is, let's say, this side, and you can connect it like this. Okay, so I've given the power to run the PLC. So PLC will simply power on. You will see this light glows when this circuit is, when you switch this one on, then this light will be on here. Fine. Now PLC's got the power. Now we need to wire up the sensors and switches and the loads from the PLC. So we all know that sensors and switches are the inputs to the PLC, and the loads like lights, like contactor coils, are loads, meaning output of the PLC. Right. Okay. So where is the inputs? Here are the inputs. 1 and 2. I don't need both of them. I just need this first one. Where are the outputs? These are the outputs. Now, given the manual, and you just see the model number and can check online, and also given in the manual, you will find out what kind of input output they be. Usually inputs are means DC fed, and this is SS is sync source. Basically, it's a common terminal, and in output we have common terminal each for one output block. So the output are Y, red with Y, and inputs are red with X. So you can see what are the inputs. These are the inputs. What are the outputs? These are the outputs. These two like that. What about the C? C is nothing but common, right? And here also SS is nothing but common. Input common, output common. Okay, so let's wire first the common thing. So in case of PLC, but usually the inputs are connected to the 0 voltage, means the black one. So let's connect it there. So black wire will be connected like this. Easy. Input common is connected. Fine. Now, and that means all these given 8 channels or ports will now be means this is actually like a terminology is the syncing. This becomes a syncing one. All right. So current will come in and sync here basically, and in these. If you want, and bottom can also be connected to SS. This time it's totally your choice. If you want to connect it to positive or negative. If you connect this as a common terminal to positive, then this whole of this becomes sourcing. But this time I've connected this to black, so all of them become syncing. All right. All right then. Now all we need to do is we need to connect the ports here with the sensors or switches. So let's do that connection. But yeah, output we'll see later. Let's first connect the inputs. So what are the inputs? First, let's say keep it simple. Let's just connect only the start button. Where is the start button? This green button. Where are the terminals? These are the terminals. I've got 4. I'll only use 2 of them. Yes. Okay. So since this is a syncing one, then I need a 24 volt coming and sync here. Okay. So where that 24 volts is coming from? Of course here. So let's take that 24 volt and connect that here. So the power is now available at this terminal, and the moment I press the button, green button here, the power will be output from this terminal. Okay. And this has to go and connect to the inputs. So let me take a slightly different color so that we do not confuse. So I'll just take this color as, let's say I'll take this color as pink. Okay. So this goes out from here and comes here. Now I can connect to any port as per the programming. So for me, if I connect this one, becomes X0, right? So as per my program, now X0 is connected to the start button. So what happens when I press the start button? Current which was waiting here will go and sync here and it comes out of this negative and goes to the negative source. Circuit is complete. My X0 is triggered. That's what happens when I press the green button. X0 is triggered means this 0 means input 0 will be glowing. It will glow basically. So what happens? This glows. This becomes live. So this is also troubleshooting. That means if you press the start button and this doesn't glow here, that means there's some problem in the wiring. Okay. Or the PLC itself. Mostly it's the physical issue. Mostly either the wiring is cut somewhere, this wiring, or this switch is faulty. So that's also a troubleshooting step. But now you understand that how the inputs are wired to the PLC. Now let me take any output that we will wire that also to the PLC. Output, let's say I trigger this switch, which is contactor, 3-phase contactor, 3-phase switch, which is a contactor. And where is the load here? This coil inside, there is a hidden coil inside I'm showing here, which is nothing but electromagnetic coil. Terminal numbers are A1 and A2. Let me wire number then A1. So this is an A1 terminal, A1, and this is A2. Where is it visible in the contactor? As you can see, A1. This is A1, this is A2. Here also A1 and A2. So this is the A2 port, you can see this is the A1 port. So I don't want to make it hodgepodge, so I will just wire it outside only. Okay, so now this coil needs power. First of all, you need to ask yourself whether this coil is needing DC power or AC power. Well, that manufacturer will decide what power does it need, AC or DC. You can read on the side. Mostly there are AC running. It could be DC also. Let's say it is a DC in this case, then this power can be directly coming from the PLC, or it can be coming through basically via our relay. So for now, I'm not connecting any relay to keep it simple. So I will just output a cable directly into the coil. Also now I will ask myself, these outputs, are they relay based or transistor based? Okay, so in that, if there is a relay based, then polarity does not matter. If they are switch, output are nothing but here these outputs are switches, whether this is a transistor based switch or relay based switch. If it is a relay based, you don't need to worry about the polarity. If it is a transistor based, well, mostly there are syncing type, right? Okay, so however you read the manual. Okay, so again, what do I do? Let's assume this is syncing type transistorized. I'll just take a complex case. Easy one would be you just simply connect this one to the terminal. Here, let's say I just connect that to a terminal. So I also take this one, same like input. You take a black one and this connect it here. Fine. So this becomes a syncing output. Okay. And the positive will go where? To the load. Where is the load? Here. So let's connect a positive here. Where is the here? So I'll just take the positive from this side, bring it here, and connect it here. There we go. So the load is connected to the one positive side, right? And the output comes from there. Let's take a different color so that again we don't confuse. Oh, let's say this one here. Oh. Okay. And this time I'm connecting this to the output. Y0. So Y0 will be as per the programming. So my contactor is connected to Y0 output. So what happens is when the contactor is outputting Y0 means closing this switch, which is there is a switch here. When that closes, there's a switch here. When that closes, current will flow in this path. It will go here like this. Okay. And obviously that will be, this is glowing that time. This output will glow here. Y0 will glow here. And then this circuit is closed here. This circuit is closed here. And the circuit is complete, meaning the current will flow from here. Give me a moment. Yeah. So the current will flow from here, 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 energize the coil, and then it goes here. Switch is already closed here. It goes up and then yes. So this energizes the contactor. So we already know the power was available in the input of the contactor, which goes in the output, and this whole thing is connected fully. That means motor starts. So it's so simple now. So what is happening? You press the start button and motor starts. So it's we have taken the most easiest of the cases with just a start. When you press it, motor starts. Okay, we have not added other level of complexity, but that holding the contact or usage of the stop button or any other sensors connected. No, nothing yet. But this in by itself is a nice wiring here. All right, now you can be asking, what if the coil is AC coil? This coil is AC. Well, that also it's not difficult. Then in that case, we cannot be using, the only difference being we cannot be using a transistor based output. We have to use a relay based outputs. So let's assume these are relay based outputs. If they are relay based outputs, then yeah, then again, it's not so difficult. Let me remove this wiring and let's wire it from AC. So where is my AC? Here is the AC. Here is the AC. Let's wire it with use some AC. So what do I do? Again, I will take one phase, connect that to the coil like this. Okay. And also is this time my common is connected not from this, obviously this one, DC supply. So I should have erased this line also. Okay, let me see if I can erase this line. Yeah, I did. So now this time the common will be connected to the AC supply. So let's first connect that to the AC supply. Common going to the AC supply. There we go. Common going to the AC. And then another phase of the AC connecting to the coil. There we go. And out, when it comes out, let's say I use a different color. It comes out. And there it goes. Very well. It goes to Y0. So this time, how is my circuit going to energize? Let's say you press the green button and PLC works and give an output. Here, this light glows. Internally, this circuit is made now. So when this circuit is made, how will the power flow over the current? So you see, we already have power in the transformer output, which is coming this way. Coming here, here, and then goes here. Energizes the coil. Going here. Circuit is complete. Going to the return. Going to transformer. So there we go. This AC source, a transformer, is driving this coil. And when the coil becomes an electromagnet, it closes this switch. These are closed, meaning circuit is made, motor starts to run. So that's about how we can make the PLC wiring here. We have taken a simple case, one input, one output. Now we will add complexity to this. We will have more number of inputs. We will add stop button. We will add a level float switch. We will add overcurrent relay switch. We can also add an auxiliary contact switch. Okay, in output side we can have these LEDs also glowing, means these are not LEDs, these are lamps also glowing. Also, we can make use of another contactor which can help us reverse the motor direction. So all these things we are going to learn in the next module. I'll see you there.